Turn on the power of the system. We need to calibrate the system before using it. Turn on the cross laser, and rotate the cross laser to aim at the opposite mark. Confirm that the vertical axis is at 0 degrees position. Install the calibration rod in the center of the goniophotometer. Take out the standard lamp carefully. Connect the connecting rod. Install the standard lamp on the calibration rod as shown in the figure. The cross laser points to the center of the small mirror. Now we need to rotate the standard lamp rod. Adjust the pitch of the standard lamp to make the horizontal laser and vertical laser reflected by the small mirror coincide with the original horizontal laser and vertical laser. The cross laser still points to the center of the small mirror after the adjustment. Otherwise it needs to be adjusted again. This step also requires a lot of patience. After adjusting and fixing, gently unscrew and remove the small mirror. Turn off the cross laser. We need to rotate the vertical axis 90 degrees, and then make the standard lamp round hole directly face the direction of the detector. Please note that depending on the different design of the darkroom, it may need to rotate clockwise or counterclockwise. Rotary actuator control panel enters 90 here. Choose clockwise or counterclockwise according to the actual situation. This is the correct direction of the standard lamp after the goniophotometer stops rotating. There is a simple wiring diagram at the horizontal axis terminals of the goniophotometer. Please use short banana plug wires to short the red terminal with the yellow terminal, and the black terminal with the blue terminal as shown in the figure. Just connect the power wires to the red and blue terminals no matter it is a standard lamp or a sample lamp on the goniophotometer. Insert the standard lamp power cord plug into the red and blue terminals of the C-axis. Turn off other lighting in the dark room, and close the door of the dark room. The standard lamps of LM are all constant current DC lamps. Please set the AC-DC switch of the cabinet to DC. This switch is the power meter sampling position switch. Always keep it at internal. The cabinet has two USB cables connected to the computer. One is the RS-232 USB converter for the AC power supply. The other one is the RS-485 USB converter for the communication hub. So the AC power supply uses one communication port, and all other devices use another communication port. Enter the computer device manager. You can see the two more communication ports at COM port. On software system configuration, the communication ports have been automatically searched for some devices before. So all of the goniophotometer, power meter, and DC power supply use this port. The other communication port is for the AC power supply. Find the calibration certificate of the standard lamp. We need the data for calibration. Click the DC button. When you use the software to control the power supply for the first time, a communication failure message may appear. Just select the DC model and communication port manually. Then enter the current and voltage of the standard lamp according to the calibration certificate. Check the CC constant current mode. Click Set. The DC power supply CC indicator is on, and the output current is exactly the same as the entered current. The voltage will fluctuate, which is normal. The real-time lux value can also be displayed on the photometer. Calibration should be done after at least 10 minutes preheating time. System configuration. There are two detector options here. The default is near-field detector. Usually one detector is enough for the goniophotometer. So if you only have one detector, do not check the far-field detector, otherwise the software will report an error. Click Candela Calibrate under the near-field detector. Enter the candela value of the standard lamp, and then click OK. The calibration distance will be automatically displayed here. The distance from the center of the goniophotometer to the detector can also be calculated according to the darkroom drawing. These two distances will be very close, but not exactly the same, which is normal. But if there is a big difference between the two distances, please contact us for help. click Synchronize Calibrate Data to save the calibration data to the computer. Then click OK. The Candela calibration is complete. Enter the DC control panel and click Reset to turn off the DC power supply. Since the current of the standard lamp is relatively large, the bulb will be very hot after use. Remove the standard lamp, put it back into the standard lamp box when it cools. Remove the calibration rod and put away. The accessory box contains a small black cover, which can be screwed in the center of the goniophotometer to cover the round hole for the calibration rod. You can write down the calibration distance. If you need to change the computer in future, you don't need to recalibrate the Candela. Just input the calibration distance manually, and then click Synchronize Calibrate Data, OK. Goniophotometer has two test methods, single column C gamma test and double column B beta test. According to the standard, the floodlights need to do B beta test, and other types of lamps need to do C gamma test. Users can also refer to local standards and do corresponding tests for your samples. Here are the steps for C gamma test. Luminance provides two C gamma test fixtures: E27 bulb fixture and large cross fixture. These two fixtures can usually hold most of the luminaires for C gamma test. We can also design other fixtures for you if you have special luminaires to test. Install the corresponding fixture to the horizontal axis of the goniophotometer. Turn on the cross laser and aim at the mark on the opposite wall. Open the software and rotate the vertical axis to make the cross laser face the fixture. Install the sample according to the cross laser. Make sure that the cross laser center point at the center of the luminous surface of the sample. Rotate the vertical axis back to the 0-degree position after installation and fixation. Now you need to rotate this handle to move the luminous surface of the sample to the vertical laser. That is the center of the goniophotometer. LSG1700B doesn't have this rotating handle. There is a hexagon socket screw under the main arm to fix the main arm. Loose this screw counterclockwise to slide the main arm. Use the banana plug to connect the power cord of the sample lamp with the red and blue terminals of the horizontal axis. Then you can turn off the cross laser. Turn off other lighting in the dark room. Close the door of the dark room. Take the AC sample luminaire as an example. Set the AC-DC switch of the cabinet to AC. Click the AC button. When using the software to control the AC power supply for the first time, you also need to manually select the AC power supply model and communication port. Enter the correct frequency and voltage, and click Set. If Set is not available, please click Reset first. Then the AC power supply start output and the power meter displays the electrical parameters. The sample is on now. Click Measure. The first step is to fill in the sample information and test information. You can also fill in after the test. Click Next. Select the type of lamps. Flood is B beta test. Indoor and roadway are C gamma test. Set the test parameters. C plane is the horizontal axis angle. G plane is the vertical axis angle. C plane symmetry options. If there is no special requirement, please always select no symmetry and no need to change. The rotation range is from 0 to 180 degrees and no need to change. The angle interval is optional from 0.1 to 90 degrees. The principle of selecting the interval is basically as follows. If the sample lamp is symmetrical and uniform, bulb, panel lights, etc., you can choose a bigger interval such as 30, 45, etc. Otherwise, street lamps, etc., you need to choose a smaller interval, such as 10, 15, etc. Bigger interval need less time to finish the test. Smaller interval need more time to finish the test but the data is more accurate. G-plane. There are two options for the rotation range. -90 degrees to 90 degrees is for samples with an illumination angle less than 180 degrees, such as down lights, panel lights, etc. -180 degrees to 180 degrees is for samples with an illumination angle greater than 180 degrees, such as various bulb lights. According to some standards, it is also need to test the backlight of the samples even the illumination angle is less than 180 degrees. Then just select -180 degrees to 180 degrees for G-axis rotation range. If there is no special requirement, always select 1 degree for G-axis interval. There are two preheating options. You can directly input the preheating time. You can also check auto preheat. So the software will automatically monitor the stability of the intensity of the sample in accordance with the standard requirements. The software will automatically run test after it is stabilized. Check this option. The vertical axis will automatically return to the 0 degree position after the test. The software will automatically save the test results. Just select the path where you want to save. Enter the file name here. Check add suffix automatically. This function is to avoid the situation that the previous test result file is overwritten if you forget to modify the file name. Click Next. If the communication of the power meter is normal, the electrical parameters of the sample will be automatically displayed here. If this option is checked, the power meter will communicate again and use the latest data after the test. Click Start to start the test. If the preheating option is checked in the previous step, the software will enter the preheating interface after clicking Start. And the test will start automatically after the preheating is over. Depending on the range and interval of the C-gamma angle you choose, the test process may take about 10 to 30 minutes. The test results are displayed in the software after the test. In addition, pay attention to the direction of installation if you test a street lamp. When the C-axis angle is at 0 degree position, it needs to be installed on the cross fixture in the direction shown in the figure. The direction of the pole side of the street light needs to be upward. And select roadway here. The other steps are the same.